Good. So, I was talking about microservices, and I'll tell you in a minute where this comes from, but you can already see from the Craft conference. My name is Boon, and I work for Novum. I don't have an impressive talk about what we do, but I did it in one slide. We eat a lot of Swiss chocolate because we're a Swiss company, and our output is really cool software. So, how this happens, we have a tradition. Other than eating chocolate, we have another tradition, and that's that whenever somebody goes to a course or a training or, in this case, a conference, then we also present it in the company. So this year, or earlier this year, I went to Craft with Norbert and another colleague. So I started preparing a presentation, and I thought, what are kind of the most interesting topics? What can I tell the company? And microservices was kind of the biggest thing. And then I get to Norby. I said, okay, do you want to join in? You know, and Norby doesn't say like, yeah, sure, I'll also add 2 slides. No. He says Raspberry Pi, Java, and other cool stuff that we can put on it. So he actually has an example. He has actually did something with it and show some cool stuff. He will talk about Java. I will not talk about Java. So I'm sorry if you just came for Java. I hope it's still going to be interesting. Yeah, these are kind of the topics. That's it. Who went to Craft as well? 1, 2, 3, 4. And you, I know. Okay, so there's at least an audience that hopefully gets to see something. About who doesn't know Craft or these conferences. Okay, these conferences are organized by Prezi and Ustream. They started with that 2 years ago or so. You see user experience, leadership, JavaScript. These are really high quality, good conferences. So I would really watch out for it. I mean, go to their mailing list, sign up for their mailing list. They keep you up to date. They don't overspam you. I'm really not advertising this for any other reason than that it's really cool. This is just a random list of topics that were there. Really random. There was many more things, just to kind of give you an idea. And it kind of made me think at one point, because you get this program and there's like time slots. So every hour there's like 3 presentations in 3 different locations. And then you kind of have to choose like which one are you going to see, right? So at some point, Norby and me and our other colleague, we're sitting there together in the break before the next session starts. And we're looking at our program, what to do next. And I start sweating it. I'm like, it's like, don't show anybody, just bluff your way through, At some point, Norby, confident, brave as he is, he says, I have no idea what these 3 are about. And I'm like, oh my God, he doesn't know either. And it made me think, what is this stuff about? What is kind of the pattern here? If you go to a conference, I was last year at Craft, it was all about big data and NoSQL, and that was kind of less this year. So I kind of asked around and checked it out. This is kind of the thing that I recognized there. This is called the Gartner Hype Curve, and they use it to kind of plot out technology trends. So what kind of cool is that I like the terms real a lot, because here it says technology triggers, so something is new, and there's a peak of inflated expectations. So we expect that it's going to be really cool and really awesome, and then we go to disillusionment. We're like, oh, it's actually total whatever. And then we figure out that it's actually not so bad. I kind of tried to plot out some things that I thought. It's really purely my own opinion. You'll find 100 charts where this is different. And it's also like, I mean, it's not a law. It's not, it's just kind of for idea. So I put continuous integration here because we all use that. It's all cool. Like I said, NoSQL in terms of these conferences is really getting less, but I do think we get more productive with it. I think in practice it's going to be used more and more. And continuous delivery I put there. Microservices I put there down. Actually, Norby will show some other trend. But the thing is that I think that, and I hope that this presentation will show that that's kind of the impression I got from this conference as well, is that people are looking a bit more realistic at it. And it's like it's not unfortunately, again, it's not the golden solution. Okay, so then to the main topic of microservice. So what we've been doing so far is this. Generally, this is what we do. Whose application architecture generally looks like this? A few here. Okay. Or this. But it comes down to the same thing. We have a box, an arrow, and a cylinder. That's really just, this is 90% of your web applications, right? So that has been kind of challenged to do it differently, and differently like this. So the idea would be is not to cut your logic or cut your tiers through the different kind of technologies that you have, or the different kind of responsibilities on a technical level, but more on a functional level. So you say like you have these different services which all have their own storage, or they might not have storage at all. They might just be consuming other services. And that kind of eventually comes down together with the user. That's kind of the most basic explanation. So kind of further, they say it's an architectural style without formal definition. So this kind of comes from experience that some of the larger companies, I will show a little list later on, kind of came up out of experience. So there's no formal standard about it. So the idea is to have many independent surfaces and layers of dependency. So these are not tiers. So it's not that these three are the data access tier or something like that. That doesn't exist. So it can be that there's one microservice directly to the UI. There might be services in the middle. We don't organize them by tiers. I wrote them here as a hierarchy, but actually it's not really a hierarchy. Well, it's not even really a hierarchy, but it's a graph generally. So you can point them as long as you don't go circular. It's just like any other dependency graph. So what's further the idea? Each service has a single purpose, and that's kind of what you know from well-known software design, modularization, that kind of stuff. It has a well-defined interface so that the consumers can use it. They're independent from each other as seen from the consumer, so the consumer does not need to access 3 other services before accessing yours, which promotes encapsulation modularity, I'll say a bit later. And isolated persistence, this is where there's kind of an anti-pattern where a lot of, apparently, I don't know, I'm just passing it through from the conference, apparently companies try to do this without these two and all going to the same database, which does not really give you the benefit of scaling, because then you still have this one big bottleneck called the database. You might recognize, or what actually, we did this presentation in the company, and one question was, okay, how is this different from service-oriented architecture from years ago? And generally, there's kind of two things that people say. On the one hand, this is not a top-down design. So this is not, IBM coming down with, this is what we're going to do now. This is something that came from the developer community. This came from bottom up. We have a problem. We cannot scale anymore, so we chop it up like this. The other difference is that these are really independent and communicating directly with each other. There's no service bus. There's no ESB involved in this, and that's another big difference. So if we go back to our classic design, as you would say it, like I said, we're going kind of, people get realistic, so it's not that we all move to microservices. We try to kind of figure out what makes sense, right? So in which case, what are kind of the good things about having just our classical architecture? First of all, it's simple. If you have a small application and you have the overview and you don't have too much features and it's a easy to understand system. I mean, in the end, we all do this grouping and architecture and spreading stuff out. We all do it to understand it, to make it fit in our head, right? So if it fits in your head this way, you're cool. You have in-process latencies. I mean, with the services that I showed you, those actually go over the wire. So there's network connections between these different microservices, which you don't have here, of course. Here you just do direct method calls, unless those are tiers. But generally, if you have it on one host, it's just method calls. You have a single code base and deployment unit, which means that you can just install one package and you're done. You don't have to maintain installations for all these 20 different services that you have. And as long as it's within the bounds of your hardware, this is efficient. I mean, it uses your resources efficiently because it just scales up to that point. And of course, we love to do queries. We love to just get data from all these different tables and put them together in one, which is super easy with this, which is a really big challenge with microservices. As your application grows and your team grows, the coordination becomes more difficult because generally in an application like this, if you change something here, the guy working on there needs to know about it because, you know, yes, ideally not, but in practice we all know that that's not how it works. Poor enforcement of modularity. That's, I will try if I wiggle this. No. Is it interference? Okay. Poor enforcement of modularity. I mean, it is like when I said, you know, you can just make a protect or a package private class just public and just call that one method there. Everybody started laughing, but it's true. I mean, that's just how that works. Poor scaling, vertical only. I mean, you can just go, like I said, up to your hardware, and then when you reach that limit, especially usually with the database, you know, partitioning that stuff or scaling that further is usually quite difficult. If something goes wrong in this one, your application is not accessible at all, so you cannot do anything, and you have to figure out where in that whole thing something goes wrong. So that makes it also a bit difficult. Build times are longer, and yeah, like I said, DB can or actually will always be a bottleneck. So microservices, there's good things about it, like I said. Also things to keep in mind, so to say. It is simple, so it is easy. Each of these is simple, or that's the goal, that they are simple, that it fit in your head, that you can understand them as a single unit, so that makes it easier. And you have this firm module boundary. If you need to call a service here, you have to ask these guys to actually implement that service, so they're not gonna, you know, doing a quick hack like you do in a regular or in a classic in a monolith is not so easy. Independent scaling and performance. So if you know, if this one is, I don't know, read access only, then you can just use a lot of caching or something like that. You can really focus on one of these to improve the performance, to see where your bottleneck is, and just look at that one. Independent deployable, so you can just take away one of the other and the rest keeps running. So that could be handy in a lot of cases. Yeah, and like I said, that's actually what I just said. You can optimally tune the performance which is specific for that thing. I drew these as cylinders because, and that's what we usually use for relational databases, but this can be any kind of NoSQL database as well, which might fit that service better, right? So you can tune that as you want. But then the drawbacks are the things that you have to keep in mind, right? These all work together, so that the whole thing, the system as a whole, can become quite complicated. Even though we try to keep them independent from each other, I mean, in the end they come together here and it needs to work, right? So you have a lot of different components to deal with, which might lead to small or will lead to small repos, but and then the dependency management. So figuring out this graph and knowing which service depends on which service, yeah, that's probably, I can imagine, it's not any easier than what you do with Maven or with your libraries in your project, right? You have the network overhead and the operations overhead. So I mean, if one of these goes down, you need to know that, right? So you need to have monitoring over all of these. So all of these need to be monitored and need to be integrated into your monitoring system, and I don't know what. So there's some work involved there. Now, if we look at the pros, and we look at the first one, right? Each unit is simple. How would you do that in a monolith? What do we have in a monolith to support this? Classes. mean, we can do this. We have this already for a long time, right? It's just because it's not enforced, we can easily break out of that. Same with modules, we have packages, right? So the thing is that the stuff that I've shown now is really technical. This is just about, on a technical level, what do you gain by this? But there's kind of also an organizational thought behind microservices. And that's the following. The idea is that these services are not just randomly picked or whatever. They're organized around the business capability, so around your features. And here's an example that you have a microservice about the billing and about orders and that kind of stuff. And that's how you organize your teams as well. So you have a team for each of these, and they manage the whole thing. So these are basically smaller sub-projects that are dependent on each other. Another thing is there, like I said, it's not just the development, it's also DevOps, so it's also the operations that's handled by the same team. So everybody is responsible for that part, which generally brings up more of a product mentality that people get than a project mentality. So people need to provide something to the other teams. So you provide your service internally to other teams. But then the question, do you really need microservices for that, or can you do that with a monolith as well? I don't know. Think about it yourself. Then there's another question. So here it's quite it's obvious: billing, orders, notification, analytics. Who actually has a project which just has billing and orders and notification and analytics? This is nobody. So this is hello world, basically, right? In real world, these are a few things in our company for projects that we have. You don't need to understand them. The question is, do you have the right granularity? Are they small enough to have a single purpose, right? And to gain from these performance improvements, and are your team fit around such a thing? Are they truly independent? I mean, like I said, these SQL queries are damn handy. And you will see there's a lot of requirements. You need to have that report at some point, which go over across of all of these. So are they truly independent in a lot of cases? And then there's overlap and reuse. Like, how do you prevent that, 3 microservices don't implement the same subset of business logic or business rules? This is, if you look back, like I said, I took this from our own projects. And it's quite easy to look, or quite easy. You can argue about it and you can talk about it. You can look at it and what makes sense. But that's kind of postpartum. That's afterwards. We already have this system. We know this. Usually this is really hard to do when you start a new system. When you start a new system, to figure out what these business capabilities are, how you're going to structure which microservices you're going to have is really difficult. And that's also kind of shows how this stuff evolved. I mean, Amazon was really, really one of the front runners with this stuff. There was really part of the company strategy to say, okay, everything has to be exposed as a service. But it comes after they also had monoliths. So usually all of these actually, eBay, Google, Netflix as well, they started out with a monolith, figured out that they couldn't scale anymore, either performance-wise or organizational-wise, and they decided to take up the same approach to split this up. Funny enough, actually only last week I read an article about SoundCloud, which followed that same path. Martin Fowler has some articles about microservices, and he was also one of the people promoting it quite a bit some months ago, and still actually. And Norby pointed out, I actually showed my slides for review, and he said, oh, look at this, what Martin Fowler wrote yesterday, right? And he says, that's interesting to add. Basically, what he says is that, okay, if you go on a monolith, then usually your productivity is higher in the beginning until you reach this certain point of complexity, and then you're kind of have a problem, because then adding new features is going to be really costly, really difficult. Whereas with microservices, yes, you have lower productivity because of this overhead of, like I said, operations, deploying, installing 20 services. But overall, in the end, it will be less costly to add new features because of this. Funny thing is, this is complexity. It's not time or anything. It's complexity. It's not lines of code. So to figure out if you're going to start a project that ends up, we're going to start a project with complexity 6.5 on the Martin Fowler. That doesn't work. So this is really difficult to figure out what you're going to do, right? Then I got back to the initial thought that I had when I showed you this hype curve, right? And I was thinking like, okay, that was kind of after the conference, and I was thinking like, okay, what are we doing here? And there was some other interesting insights in kind of, generally how we approach software. There's some interesting talks about that as well. And one thing was like, what is the question was kind of, what is the goals? What are the goals of software development? And I Googled it myself, because I didn't believe this guy who was talking about this. But he was right. It was about maximum functionality, code, reliability, delivery, high quality software. The focus is all on the software, on the code. But this guy had kind of an idea, like what do we do this for? And his statement was, what we are actually trying to do for our customers is to sustainably minimize the lead time to business impact, with business impact being that kind of commercial or that goal that the company, that your customer is trying to achieve, be it, I don't know, more exposure on the market or getting higher values for this or that, or more efficiency in a certain area. Lead time, wall clock time, and sustainably, it kind of gets back to the Martin Fowler image. It's not about just version 1 and everybody is happy, and then a year later the competitor is ahead of you again, and then you cannot add more because it's so complex what you're maintaining. So the main message here is that the goal is actually not to produce software. Software is not the end goal. Software or code costs money to write, to maintain, to understand for people. It needs to debug. It's not an asset. It's a cost to maintain software. And it's not the first time that I heard about this. I read an article about it earlier, which I wanted to share with you. Who knows this guy, or actually this image? Few. Yes, it's the coding horror, which comes from this book, which it's his Bible, which is quite a confession, because actually I wanted to warn everybody and tell people to not start their tortures, because it's actually published by Microsoft. So it has nothing to do with Java. It's about software engineering in general. He's right, it's a Bible. Read this book. I promise you that if you read this book, it will make you a better software developer, whether you're junior, regular, senior, or what kind of level. This has some really good points in it, regardless of the language. It's actually so good. There's 2 editions, Code Complete 1 and Code Complete 2. That's actually the title, Code Complete 2. It's about, I think it must be 10 years old or something like that. It's around for quite a while. It's still very relevant. But if you go to Amazon and you type in Code Complete, it will try to autocomplete it with the number 3, which doesn't exist. There's just 2. So people just want Code Complete 3, but it doesn't exist. So, anyway, I didn't want to talk about the book. There's another place where this is being used, and that's the blog from Jeff Atwood. Who knows this one? Either the blog or Jeff Atwood. Jeff Atwood is responsible for solving 80% of your bugs, and that's because he is indeed one of the guys behind Stack Overflow. He has this blog, and he wrote about this. The best code is no code at all. So I would really Google it, look it up, and read it. Conclusions from my side. Microservices, cool. Scales, really good. And don't write code anymore. These are the talks that I based it on. If you go to the website here, they're all on Ustream, so you can check all these and many more talks. It's really worth it. I'm not going to do questions now. We do that at the end together with Norby. So give us 1 minute to switch.